Hello guys. So here I got one question under the topic of forces, okay, summation of forces and summation of moment or object at rest, okay. So object at rest, which is in equilibrium, and then uniform. Okay, involve the word uniform rod. Okay, what is uniform rod? Uniform rod, that means we have a rod, okay, and the mass, okay, the total mass of the rod is said to be acting at one point where we can assume the point is at the center, okay, at the center of the rod. So let's say the length of this rod is x, so that means the distance between point A to B is equals to x over 2, and here is over 2 from B to C. So that is uniform rod. Okay. So here in this question we have uniform rod and it is at rest. So we can apply this concept, okay, first concept, and then at rest, okay, whenever the problem said it is at rest or in equilibrium, okay, so we can apply the concept of equilibrium, which is the summation of force at any direction is equals to 0, and the total moment of force acting at a point, okay, moment force acting at any point on the objects is equals to 0. Or we can say that all total clockwise moment, okay, here. Also, we can see that total clockwise moment equals to total anti-clockwise moment. So this is only applicable for object at rest or in equilibrium. Okay, let's start our problems here. Okay, let me write it again. Okay, for our reference. So given the problem here, so what we have here, this rod is said to be an uniform rod. So the weight of the rod should be acting at the center of the rod. Okay, approximately here. So here at point, let's put it as PQR reaction, and then let's put it S. Okay, S. So at point S, the weight of the object of the rod itself will acting on this point, where W or the weight, okay, uniform rod has weight 70 Newton. So here we have one force. And then it rests in a horizontal position on two smooth support. So we have two supports, P and Q, where AP is 0.5. So already drawn there. Reaction on the rod at P. So at P we have reaction force. So RP, let's put it as RP as 20 Newton. So we have two forces here. Find the magnitude of reaction on the rod at Q. So Q, we have another forces. We should have another forces since the rod is in contact with the support. So we should have the reaction. So reaction here we just already did as RQ. So how to solve the problem? So this problem, the question number 1 only give us 2 marks. So that's mean it is an easy problem. So since the system is at rest, okay, we can apply either this one or this one. Okay, total moment or total forces in any direction. So the easiest way is we deal with this first rule first. Okay, we take the summation of forces at any direction is equals to 0. That's mean for this problem, I will try to solve the forces vertically first. Vertically first. Okay, vertically. So let's try sum all of the forces vertically. That means we should get the total forces equals to 0. The summation of force vertically equals to 0. Okay. Okay, let's try this. So summation of force equals to 0. So 0 equals to, so here we have 1, 2, 3, three forces. So W plus RP plus RQ, we should get equals to 0. And then since this all of the forces are vectors, okay, so here I will take the force acting downward as positive, or maybe, okay, downward is positive and upward as negative. But it's up to you. You can take it as upward negative, downward positive. Okay, it's up to you. So W is downward, so it should be positive. So 70 Newton plus RP. What is value RP? It is 20 Newton. Okay, 20 Newton. And then we have RQ, okay, plus RQ. Okay, RQ. So let's find RQ. So RQ equals to 70 Newton minus, okay, 70 Newton. Oh, sorry. Okay, here I have a small mistake here. Okay, what is my mistake here? So since I choose to consider all of the downward forces as positive, so upward negative. So here I should put it as plus negative 20 Newton. Okay, so here should be plus negative 20. Why negative? Okay, because RP here is acting upward. Okay, so upward negative. RQ, we don't have the value, so just put it as RQ. So let's continue. Continue here. So here plus and minus, I will get minus 20 Newton plus R. Sorry. So here, let's do it again. Okay. So here, the moment of force is equal to 0, which is equals to 70 minus 20 plus RQ. So find RQ, we will get 70 minus 20, and then bring to the other side, we will get minus 50 Newton. So why minus here? Okay, why negative? Since negative means RQ is acting upward. Okay, since I already consider upward force as negative, so whenever I get negative value, that's mean RQ is negative. This is the magnitude of force, 50 Newton, but it acts on the point in the direction of upwards. Okay, upwards. So RQ, I will get, okay, RQ. Here the question asks for magnitude. So you just need to write RQ equals to 50 Newton. Negative is just the direction to show it is upward. Okay, so we have settled this one. Okay, now we move to the next question. Okay, we move to the next question. The second question. Okay, second question. Let me remove all this one. Okay, let me remove all this one. Okay, so let's remove. So the question asks us to find the distance of AQ. So AQ, okay, let's just draw again the rod. Okay, let me draw the rod. Oops. Okay, the rod. So let's see, this is the rod. We have a few points. Okay, we have A, P, S, Q, and B, and after that. Okay. Given AP is 0.5, and then we know that since it is uniform, AS equals to 1.5 meter. How to get 1.5? Okay, 3 divided by 2 is equals to 1.1. Okay, divide by 2, we get 1.5 since it is uniform rod. Then what else we get? Okay, AB is 3 meter, of course. AB is 3 meter. And they want us to find the value of AQ. Okay, sorry, AQ. So just mark it with different colors. We want to find this value, AQ. Okay, so AQ, from what we have here, AQ, okay, AQ is equals to AQ equals to AP plus PQ. Okay, AP plus PQ. Okay, we already have the value of AP here. Okay, AP is equals to 0.5 meter plus PQ. So that means we need this distance. Okay, we need this distance. P and Q. What is the distance between P and Q? So for that reason, okay, I will try to use this one, okay, where I will add all of the moment, and then I should get equals to 0. Okay, I should get equals to 0. So here I have at point, okay, I will take the moment at summation of moment at point P. That means here, this is my pivot, okay. So that means when I take this moment at P, okay, so these forces acting at P, I will eliminate. Okay, I will not have to deal with these forces because these forces acting at the point where the point is our reference or our pivot. Or maybe you can show this by using, okay, we can calculate, of course, we can calculate the moment of, okay, moment of RP at P. RP at P is the forces RP times the distance. So what is the distance between this RP and this point P? It is equals to 0. So since the answer is 0, so we don't have to add in our calculation. Okay. So moment at P, okay. Of course, you can add it. Okay, you can add it. So let's make it as, so the force at RP times the distance. So distance between RP and P is 0. Okay. Plus W, okay, W, the distance between S or between W and P. So what is the distance here? Okay, since AS is 1.5, so PS, okay, the distance P to S is 1.5, okay, oh, sorry, okay, 1.5 minus 0.5. So 1.5 minus 0.5 plus, what are the forces? Okay, other forces is RQ. We have RQ. So RQ, the distance is from Q to P. So this is the distance that we want, PQ. So PQ. Okay, this is our equation. And then we need to determine either the value is positive or negative. You can take it clockwise as positive and anti-clockwise moment as negative. It's up to you. So the total of moment should be equals to 0 since it is in equilibrium or at rest. And RP times 0, we will get 0, okay, plus W 1.5 W. Okay, we look at W. So here is W, and this is our pivot point. Okay, so if we look here, what kind of moment will produce by this force? Is it clockwise or anti-clockwise? So it is clockwise moment. So clockwise moment, I already assume that clockwise moment, or I already consider that clockwise moment as positive. So it is positive. W times the distance 1.5. So we get 1. Here RQ, what about RQ? RQ and point P will give anti-clockwise moment. Okay, you can see here. it will make the object tend to rotate anti-clockwise. Okay, as P as our pivot. So here plus RQ, we will put it as negative since it is anti-clockwise. So negative RQ times PQ. Okay, so this is the distance. And then let's answer. Okay, let's just substitute the value that we have. 0 equals to W. Okay, W. What is the value of W? Okay, sorry. W is 70 times 1 minus, okay, plus minus, we got minus RQ. Where is the value RQ? RQ we already calculated before. RQ is equals to 50 Newton. Okay, 50 Newton PQ. Okay, PQ. This is one term. PQ. So here you can find PQ, 50 PQ equals to 70, and then PQ equals to 7 divided by 5, or equals to 1.4 meter. So this is the distance of PQ, P to Q, P to Q, okay? But the question asks for AQ. So AQ, we need to add the number. So AQ here, we have already written above AP equals to PQ. So AQ equals to AP, which is 0.5 meter, plus PQ, 1.4 meter. So we should get 1.9 meter. Okay. So that is how we deal with problem involving uniform object and an object in equilibrium state by using summation of force and summation of moment at any point. So hopefully you can understand, and if you have any question, you may write your comment below. So thank you.